So metals and non-metals questions. A non-metal X exists in two different forms Y and Z. Y is the hardest natural substance whereas Z is a good conductor of electricity. Identify X, Y and Z. So X is the carbon, Y is the diamond as it is the hardest natural substance because the diamond has a millions of carbon attached which has the four bonds with the other four carbon atoms. So it is one of the hardest known substance. And Z is a graphite as it is a good conductor of electricity. So the graphite is the only non-metal which can able to conduct the electricity because the one carbon atom is bonded with other three carbon atoms. So one electron is left free on the each carbon. So that will conduct the electricity. So why does the calcium float in the water? It is because the hydrogen gas is formed when sticks to the bond of the calcium, so therefore it floats. When the calcium reacts with the water, it liberates the hydrogen gas. Name me a non-metal which is lustrous and a metal which is non-lustrous. Iodine is a non-metal which is lustrous. Lead is a non-lustrous metal. Okay, so the iodine which is a non-metal basically. So usually the lustrous is the property of the metals and non-lustrous is the property of the non-metals. So the only one case is the difference. So here the iodine is a non-metal, so which is lustrous in character of the metals, and the lead is the non-lustrous, which is the characteristics of the non-metal. So which gas is liberated when a metal reacts with an acid? How will you test the presence of this gas? So the hydrogen gas will be liberated. So when you bring the burning matchstick near to it, the hydrogen gas will burn with a pop sound. So that is the confirmation of the hydrogen gas. Name the metal which reacts with very dilute HNO3 to evolve hydrogen gas. Magnesium. Name the two metals which are found in the nature in the free state. So gold and the silver because they are very unreactive metals. The way the metals like sodium, magnesium and iron and water is an indication of their relative positions in their reactivity series. Is the statement true? Justify your answer with examples. Yes, sodium reacts exclusively with the cold water, so it is the most reactive one. So magnesium reacts with the hot water. It is less reactive than the sodium. Iron reacts only with the steam, which shows it is the least reactive among the three. Because steam means it contains the hot air. So what will happen over here is because that heat is needed for the iron to react. X plus Y SO4 gives X SO4 plus Y. Y plus XSO4 gives no reaction. Out of these two elements, X and the Y, which is more reactive and Y? So X is more reactive than the Y because in the first reaction, it can able to displace the place of the Y. But in the second reaction, the Y cannot able to take the place of the Y. So that's why there is a no reaction. So X is more reactive than the Y. What is an alloy? State the constituents of the solder. Which property of the solder makes it suitable for welding the electrical wires? Alloy is a homogeneous mixture of two or more metals. One of them can be a non-metal also. Solder consists of the lead and the tin. It has a low melting point which makes it suitable for welding the electrical wires. So using the electronic configurations, explain how magnesium atom combines with oxygen atom to form the magnesium oxide by the transfer of the electrons. Magnesium, which is having an atomic number 12, so its electronic configuration is 282. So there is 2 electrons in the outermost shell. So the magnesium easily loses the 2 electrons and it forms the Mg2 plus and it gets the octet configuration. Oxygen, which is having atomic number 8, so the electronic configuration is 2,6. It needs 2 electrons to complete the octet. So oxygen is 2,6. It gains the 2 electrons and it becomes the oxygen 2 minus. So, when it gains the two electrons, it gets the stable octet configuration in the outermost shell. So, Mg plus 2 and the oxygen minus 2. So, the formula is MgO. So, when a metal X is placed into the cold water, it gives a base Y with the molecular formula XOH. Molecular mass is 40 and liberates a gas Z which easily catches the fire. Identify X, Y and Z. So answer is 2Na plus 2H2O gives 2NaOH plus H2. So X is the sodium, Y is the sodium hydroxide and Z is the hydrogen gas. Write chemical equations that shows aluminum oxide reacts with the acid as well as the base. So this character we call it as a amphoteric character that can able to react with both acids as well as the base. Al2O3 plus 6HCl gives 2AlCl3 plus 3H2O. At the same time, the Al2O3 can able to react with the 2NaOH and it forms 2NaLO2 plus water. Name the main ore of mercury. How is mercury obtained from its ore? Give balanced chemical equation. So cinnabar, it is a ore of the mercury. So its formula is HgS. So the mercury is obtained from its ore by roasting. So roasting is nothing but heating in the presence of the oxygen. So that we call it as a roasting. So HgS plus O2 gives Hg plus SO2. What is thermite reaction? How is it used to join the railway tracks or the cracked machine parts? Okay. So when the aluminium is heated with Fe2O3 to get the molten iron, so it is called the thermite reaction. So Fe2O3 plus 2Al gives Al3 plus 2Fe. Name the method used to extract the metals of high reactivity. So electrolytic reduction. How can the metals at the top of the reactivity series be extracted from their ores? Explain with an example. So these metals are extracted by the electrolytic reduction. Example, aluminium is obtained from the bauxite by the electrolytic reduction. Name any one alloy made from a metal and a non-metal. Steel, made up of the iron and the carbon. So two metals, brass, it is made up of copper and the zinc. Give two methods to prevent the rusting of iron. So one is the painting, another one is the galvanization. Name the ores of the following metals. Mercury, it is a cinnabar. Zinc, zinc blende is the ore. Explain with the help of a diagram how copper metal can be refined. Label the important arrangements in the experimental setup. So this is the diagram for the electrolytic refining. So we have to take the pure metal as a cathode and the impure metal as an anode, and we have to take the copper sulfate as the electrolytic solution. So this we call it as a anode mud. So once the electrolysis started, so what will happen? The copper from the impure metal is moving towards the cathode and it will deposit over here. So the mass of the anode decreases, the mass of the cathode increases. So what are the impurities which is associated with the impure copper metal that will get settled down? So this impurities mainly contains the selenium, gold, silver, etc. So here at anode what will happen? The copper which is in the impure one, so that will oxidized. Oxidized means the loss of electrons takes place. The two electrons it lost and it becomes a Cu2 plus. At cathode, so what will happen? Once it forms the Cu2 plus, the cathode is having a negative charge. So it will move towards the cathode and it will accept the two electrons because at cathode the reduction takes place. So gain of electrons. Cu2 plus is gains two electrons and it forms the Cu. It's a pure. With the help of the suitable example, explain how ionic compounds are formed. State any three general properties of the ionic compound. compounds. Answer. Ionic compounds are formed by the transfer of electrons from the chlorine gain one electron and the chlorine gain one electron forms CO minus. So Na from the sodium atom it gain moving to the electron moves to the chlorine and it forms the Na plus and the Cl minus. So general properties of the ionic compounds are they are usually the solids at room temperature which has a high melting point and they are readily soluble in the water. They conduct the electricity only in the molten state as well as the aqueous solution. Explain with an example how the metal X, which is low in reactivity series, and the metal which is high in the reactivity series are obtained from their complementary reduction process. So X is obtained by the chemical reduction, Y is obtained by the electrolytic reduction. Write the electronic configurations of sodium and chlorine. Show the formation of the sodium chloride from the sodium and chlorine by the transfer of the electrons. So the sodium which is having the electronic configuration, so 281. Chlorine is having 287. So the sodium loses the one electron which is present in the outermost shell and it becomes the Na plus. At the same time the chlorine can gain the one electron so which completes the octet. So Cl plus E minus gives Cl minus. So the moving of electrons from sodium to the chlorine it forms the Na plus and the Cl minus. List any two observations when a highly reactive metal is dropped in the water. So it metal will catch the fire and the alkaline solution is formed when it turns the red litmus blue. So this confirms the it is basic in nature. The reaction of the metal X with ferric oxide is highly exothermical. So X is obtained from its oxide by electrolytic reduction. Identify X and write its reaction with ferric oxide. So X is aluminium. So the aluminium can able to react with the iron oxide and it forms the aluminium oxide plus iron. Give reason to justify that aluminium oxide is an amphoteric oxide. Also give another example of the amphoteric oxide. So amphoteric oxide is nothing but it can able to react with the acid as well as the base. So Al2O3 can able to react with the NaOH which is a base and it forms the 2NaAlO2 plus water. At the same time, the Al2O3 can also react with the hydrochloric acid and forms the AlCl3 plus hydrogen gas. So another example for the amphoteric oxide is the zinc oxide. Mention constituent metals present in the bronze. The bronze is an alloy which contains the metals copper and the tin. What is the valency of the silicon which is having atomic number 14? So its valency is 4. What is the valency of the phosphorus with atomic number 15? It has a valency 3. What is the valency of an element atomic number 35? So which is present in the group 17. So its valency is 1. This we have already seen. Okay. Arrange the following metals in the decreasing order of reactivity. Sodium, potassium, copper and silver. Okay. So the potassium is a high reactive metal, then sodium, then copper and last is the silver. An ore on heating in air produces the sulfur dioxide. So which process would you suggest for its concentration? Describe briefly any two steps involved in the conversion of this concentrated ore into the related metal. It is concentrated by the Froth flotation process. Next is the roasting. So roasting is nothing but the ore. We have to heat it in the presence of the large supply of the oxygen. So ZnS plus oxygen gives zinc oxide plus SO2 gas. So once it converts into the zinc oxide, we have to do the reduction with the carbon. So it forms the zinc plus carbon monoxide. Give reasons for the following observations. Ionic compounds in general have the high melting and boiling points. The ionic compounds have high melting and boiling points. So due to the strong force of attraction between the oppositely charged ions. Highly reactive metals cannot be obtained from their oxides by heating them with carbon. It is because these metals themselves are the strong reducing agents, therefore cannot be reduced by the reducing agent like carbon. Copper vessels get a green coat when left exposed to air in the rainy season. So because it can easily react with the carbon dioxide, oxygen and the moisture to form the green colored basic copper carbonate CuCO3.CuOH twice. State reason for the following observations. The shining surface of some metals becomes dull when exposed to air for a long time. So it is because the metals can react with the atmosphere and form the surface compounds which makes it dull. Zinc fails to evolve hydrogen gas on reacting it with the dilute nitric acid. It is because dilute nitric acid is an oxidizing agent and therefore the zinc gives nitrogen monoxide and not the hydrogen gas with the dilute nitric acid. Metal sulfides occur mainly in the rocks, but metal halides occur mostly in the sea and the lake waters. It is because the sea water contains the sodium chloride, so due to which the metal halides are formed, whereas the sulfur is formed below the rocks. So therefore, the metal sulfides are formed in the rocks. State reasons for the following. Electric wires are covered with rubber-like material. It is because the rubber is an insulator and does not allow the current to flow through it. Second, from dilute hydrochloric acid, the zinc can liberate the hydrogen gas, but copper cannot. So it is because the zinc is more reactive than the hydrogen, so therefore it can easily displace the hydrogen from the dilute HCl, whereas the copper cannot because it is less reactive than the hydrogen. Sulfide ore of a metal is first converted to its oxide to extract the metal from it because it is easier to reduce the oxide ore as it compares to the sulfide ore. What is meant by corrosion? Name any two methods used for the prevention of the corrosion. So the corrosion is a process in which the metal reacts with the substances which is present in the environment and forms the surface compounds. So how to prevent over here is the first method is galvanization. It is a process to prevent the corrosion of the iron. The second one is the electroplating, so which can you can able to coat the other metals, so which is used for the preventing the corrosion. Suppose you have to extract the metal M from its enriched sulfide ore. If M is in the middle of the reactivity series, write various steps used in the extracting this metal. Concentration of the ores. The sulfide ore will be concentrated by the froth flotation process. So the sulfide ore will be collected in the froth, whereas the gangue will be left behind. So roasting, the sulfide ore is heated strongly in the presence of the oxygen to form the metal oxide and the sulfur dioxide. So 2M is nothing but the general form for the metal. Ms plus 3O2 gives 2MO plus 2SO2. So reduction, next step is to remove the oxygen from the metal to get the metal free in state. So MO plus C gives M plus CO. Then electrolytic refining. So impure metal M is purified by the electrolytic refining. Impure metal is taken as an anode. Pure metal is taken as a cathode. Soluble salt of the metal is taken as an electrolyte. So impure metal forms the metal ions which gain electrons and they form pure metal at the cathode. Distinguish between the ionic and the covalent compounds under the following properties. First one is the strength of the forces between the constituent elements. So the ionic compounds have the high strong forces of attraction. So the covalent compounds have the weak forces of attraction. Next one is the solubility. Ionic compounds are readily soluble in the water, but covalent compounds are insoluble in the water. Conduction in the substances. So the ionic compounds conduct electricity in the aqueous solution, So the covalent compounds, they do not conduct electricity in aqueous solutions because they do not contain any free ions or the free electrons. Explain how the following metals are obtained from their compounds by the reduction process. The metal M, which is in the middle of the reactivity series, metal N, which is high up in the reactivity series. Okay. So the metal M, which is in the middle of the reactivity series, is reduced by aluminium. So 3MnO2 plus 4Al gives 2Al2O3 plus 3Mn. The metal N will be obtained by the electrolytic reduction. Example, aluminium is obtained by the electrolytic reduction.